All right, we're back. Um, this time we're going to be looking at a new book that I got because I was looking at a lot of these job postings, and there's a lot of jobs that are mentioning DevSecOps, right? And um, so I was like, what is DevSecOps? And basically, it's the addition to DevOps. Except it's basically they've added security, cybersecurity in it, and so I found it interesting. Anything cybersecurity, um, I'm gonna want to study, right? So about this book, it's called Concepts and Practices of DevSecOps. Crack the DevSecOps interviews by Ashwini Kumar Rath. So, um, I was looking at this and I was like, this looks like an interesting book. So I bought it. It was like $20 on Amazon. I always get the digital copies, and I was reading through it, and it seems pretty interesting. So I'm thinking, let's see if we can get through this book and get a little bit more knowledge on this DevSecOps concept. And I guess this actually goes over, I guess, some tools too that they use, and remember, concepts and frameworks and programs and all this type of crap that we have in the industry, um, are going to have tools to, people are going to make tools to make people's lives easier within the frameworks or programs or methodologies and stuff, right? So this is going to have some tools that they use in the industry, but I don't think it's going to go through um, technical with them, right? But I think this is just basically, like it says, for the interviews, and it's going to go over the concepts, right? And some tools they use and how they use them, which is fine because um, in reality, you're going to use DevSecOps out in the field, right? So you're going to get the experience in the field. But if you're applying for a position that says, hey, DevSec, how many years of DevSecOps do you have? I'd put one, or because if I read this book and I understand the concepts and the practices, and it's not really technical. Um, I mean, of it, and it's you could probably get away and pass the interview if you say no. I know what DevSecOps is. Ops is. I know how it functions. I know what tools they use, and I'm ready to give it a shot in the real world. I don't know. That's what's like. Um, that's a whole nother video right there. I mean, it's so ridiculous what these um, of how these companies are going. They're destroying faith in the individual, right? And they want proof that you've got so and so experience with something like DevSecOps or whatever, anything, right? And it's like, really, um, how am I going to get the experience if I don't get a job, right? But you've studied it and you're ready to rock, right? So I don't know. Anyways, let's get through this book. Let's go through this book, and I'm gonna go through the first chapter of this book, and that's it. And we're gonna learn a little bit. We're gonna talk about things, and we're gonna discuss it, and it's gonna be fun. We're learning something new, right, in cybersecurity. So here we go. Oh yeah, this is by I probably already said it, by Ashwini Kumar Rath. Rath. All right, concepts and practices of DevOps. Now, what we do is we are going to skip the dedications. We're going to go through a brief summary of who he is. Ashwini Kumar Rath is an accomplished entrepreneur, prolific writer, and seasoned DevSecOps consultant. That's all I want to know, right? You want to know about the reviewers. I don't care about his acknowledgments. I usually read the preface, but I don't really care, right? Just gonna go through the chapters and who this book was written for. This is important here to watch the code bundle and colored images. The code bundle for this book is also hosted on GitHub, so we're gonna open this up and I'm gonna save this. That way I can refer to this. Apparently, it is gonna have some certain in chapter 3. It is gonna have some code text 1. So I don't know if we're gonna do something practical. I have no clue. I've got it right there ready, okay? And this is always stuff that you got to do when you're reading these books and you're self teaching yourself or whatever. You're doing it in school. Maybe they'll have you read this book in school. Who knows? You always look for the GitHub or whatever, wherever they have their code, if they have it in the book. Makes it a lot easier to learn, okay? We take immense pride in our work at the, we don't care about that. And we're not going to interested in becoming an author. All right, that's it. We're going to go through the table of contents too. We're going to make it a nice surprise. It's like a pretty big book. All right, so I think it already started. All right, chapter 1, security and DevOps introduction. While DevOps promises a great deal to different stakeholders, security has been an exclusive focus for any software development team. So this is primarily for software development. I forgot to say that. So DevSecOps, usually DevOps is for um, software, right? So cybersecurity is embedded in the DevOps now, so it's called DevSecOps, and it's the development of software for a company, right? And you got to remember, a lot of companies you're applying for, even cybersecurity, are going to be programming. You're going to be looking at code. Some of them, you're going to be, creating code, looking at for because what you're doing is I would say cybersecurity and programming go hand to hand. Okay, but a lot of people don't say that, and you could be a cybersecurity professional without programming. Of course you can. Um, but the thing is that you need to learn programming. Learn some programming if you're going to be a hacker. You're going to be anybody in cybersecurity, even on the programming side, right? Where you're just making frameworks based on NIST or ISO or whatever framework you're working with. You want to understand code, right? Front end, back end, HTML, Python, C sharp, anything, right? You want to learn command line. You want to learn all that because that's where it's at. Okay, that's where you know you're gonna understand the fundamentals that link everything together, right? Because that means you're versatile. You can work in programming. You can work in any field of security, and you'll be successful, right? And then if you don't want to look at code at all, then you're probably going to care about DevSecOps, right? But I recommend you do, right? Learn to program. It's good for your creative juices. It's I mean, it takes at least a couple years to learn even how to just read programming, and it sucks sometimes. But once you get through it and you start programming, you'll understand what I'm talking about. You'll understand why. It's linked with cybersecurity. Okay, and all factions of cybersecurity. Um, all right. That being said, yeah, it's software. Traditionally, companies outsource the security audit to an external agency or keep the stuff separate from a group of security experts. Moreover, all security management functions start after a software version is deployed into production. Such a scenario experiences a few to and fro exchanges that include tool based scanning and manual testing by the security team on one hand, and the resultant efforts of troubleshooting by the software or IT team on the other hand. Consequently, it significantly increases the time of DevOps cycle and nullifies the fundamental purpose of DevOps, which commits to faster software delivery. Let us dive into the first chapter, structure. In this chapter, we will discuss the following topics: relooking at security operations, shifting security left, adopting DevSecOps key changes, security controls, documentation and security, threat modeling, security policies, infrastructure provisioning and security, code, commit, release and security, use case, Internet of Things applications or IoT applications. Objectives. This chapter offers an insight into the security aspects of software system and their management from the perspective of DevOps culture. We discuss the significant technological advancements, tools, and practices that have changed how we treat and incorporate security into the scheme of things. While the chapter serves as a solid introduction to DevSecOps, it also builds on broader frameworks for later chapters. Relooking at security operations. With the rapid adoption of cloud computing and remote working, the IT infrastructure is moving out of the cozy confines of office networks. Security has been more important than ever before. In this section, we shall relook at the security operations SecOps and how it fits into DevOps. Before we proceed further, let's review what a DevOps cycle looks like. So now it's going to explain what DevOps is, right? A DevOps cycle is a famously illustrated with an infinity loop, right? Broadly running over 6 stages. Design. You design a new software and implement the existing and improvement to an existing software or even modification to the software to align with requirements, right? You code. The phase includes programming activities of coding, compiling when needed, and testing the software units. Integrate. While different software developers work on different units, integration does the process of merging the changes into code base that will function as the designated software system. Deploy. After integration, the software system needs to be deployed at one or multiple server locations as per the deployment architecture. Operate. Users start using the system. They can be selected users groups during a pilot or an actual end user. Software design. Monitor. While the software is in use, its accuracy, usability, and performance must be monitored. Adequate feedback is gathered in the next cycle in the loop. The monitor stage of the cycle feeds the design stage. Next loop, thus creating infinite evolving software systems lifecycle. Hold up. The monitor stage of a cycle feeds the design stage of the next loop. Okay, so it just keeps going and going and going. Thus creating the infinite, evolving software systems lifecycle. So it never just stops, basically. Every business and anybody that's been a software programmer knows that it never stops. Something always goes wrong. I mean, couple years later, you'll have a bug. Somebody will be like, "Look, this is broken. Fix it." And then you have to go in and say, "Well, what happened?" Nothing's perfect, but yeah, that makes sense. Every business owner or manager loves it, but they would expect the software to have minimal defects yet great security controls. They would also expect that each cycle should be fast as possible to match the business goals and should lower the effective blah 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 yakety smackety. It should be noted that the different authors or practitioners described in this loop is slightly different ways. However, they fall broadly into the ones we have described above. The function of the DevSecOps infinite loop is just illustrated in Figure 1.1. So design, code, integrate. So this would be when you design your code, you make your SDDs, your software design documents based off your software requirements. Then you code it, then you integrate it. So this coding right here has a lot of stuff to it. Then you integrate it into the, I guess, your VM, maybe not even your system yet. Work out more bugs, and you deploy it onto the actual system. Work out some more bugs, and you run it and operate would be like a, pre test of it before the customer gets it or you get it or whatever. And then after that, if it's good, then you keep monitoring it. And you found right here, you found something wrong. Oh, there's a bug. 5 months later, you got to redesign it. You got to refix it, fix the code, then put it in the VM. VM. Oh yeah, it's good. Test it on the VM, whatever. Now we're gonna put it on the system. And then we're gonna, because you fixed it, now you're gonna put it over here, and then it just keeps going. So that makes sense. I'm not gonna memorize any of this crap. Design, code, integrate. I mean, you can, but it's like Einstein said. I love that saying. When he said, "Why do I have? Why would I memorize something that I can look up?" But the thing is, you can look anything up. So I don't know what he meant by that. There's stuff because I'm sure there was books. There was books on everything he was learning, so he could just look at everything. So in other words, don't memorize anything. What the hell do you mean by that? You got to memorize some things. But I mean, if you're a electrical engineering technician like I was, we had to memorize Ohm's law. I'd say after 5 years, I had to Google it. I had to revisit it. So maybe that's what he means. I don't know. Anyways, it seems like they want us to memorize the God. See, I can't even remember what it is. The OSI model. And I don't want to. Anyways, I could look it up. But please do not throw out sausage pizza away. Anyways, but I know how all of it functions, right? But see, design code, I don't know. But a lot of people, they memorize this: integrate, deploy, operate, monitor, design code, whatever. Anyways, let's keep moving on. Conventional SecOps with DevOps. This is what I want to know. Let us cite an example to understand the traditional methods of SecOps or security operations. Once a software agency which had recently adopted DevOps was taken with the development application to its customer. Was tasked with the development and application for its customer. Man, that made that sentence way different. The customer, the customer had their own chief security officer and chief risk officer. During one of the project review meetings, these two officers wanted to understand the software development cycle to eliminate process-related risk and a transparent process. The agency had automated the infrastructure provisioning on the cloud, and CI/CD pipeline. This could complete one DevOps cycle in less than a day. However, each software release moving through the production, they will refer to the security vendor, who will do a round of penetration testing and provide the list of findings, security issue observed, for the software development team to review and respond. The software team would do the following. If a finding is a false positive, they will ignore it. If the finding is high risk category, they will fix it. If the finding refers to low risk category, they may fix it or ignore it. So this is all part of risk management. I forget what this is called. It might be just DevSecOps. If it's a high risk, they got to fix it. If it's low risk, they can fix it or whatever. After the above task, the software team will respond to the security team. The security team will do another round of penetration testing. Here, the security team may add them to the configuration to ignore this round. Items marked false positive, then they issue the findings for the development and the system admin team to review and address. So they have a third party doing their sec part. Issues with conventional SecOps. This process will continue until the security team is happy and thumbs are up. The disadvantages of this process are penetration testing and addressing the issues may take up to a week at least. And development and system admin teams only become aware of the security issue after the software goes to production. We may argue that we cannot do similar penetration testing rounds when the software goes to beta rather than waiting for production to release. Well, it depends on how much the business can wait. As such, an effort will further push the release date for more than a week. And most companies can't wait. They're on deadlines. They've already prepaid for it. An illustration of the relative time lapse due to conventional SecOps in comparison to DevOps cycle is given. So, one release cycle, DevOps cycle less than 1 day, security operation greater than 1 week. Yeah, it takes longer. Well, because you're doing the security part of it, risk assessments, all that. Essentially, the above two reasons trigger a transformation and acquiring a new security perspective. While practicing DevOps, the resulting process, tools, and techniques come in a framework called DevSecOps. Shifting security left. Security is immersed in DevOps cycle in this new paradigm. To understand this, let's understand the what? Let's understand the kind. Items marked as false positive when they issued, and if you don't know what false positive is, you can gotta Google that. Oh, man, weird. That's the old one. Sorry, never mind. Google that anyways. Of security interventions we can make given a chance in different stages of DevOps cycle. Now onwards, we shall call DevSecOps cycle. Thus, yes, the infinity loop of DevOps is still valid in DevSecOps. The above discussion points to the requirements that security is treated as an integrated way with DevOps. Okay, hold up. Let me read that again. The above discussion points to the requirement that security is treated in an integrated way with DevOps. Okay, so we're integrating it. It should not be managed separately. We still need to answer how security integrates. First, it is pretty clear that security comes in the middle of the word DevOps, saying that the security aspect is to be considered at each stage of the infinity loop. This is what we call shift left. We no longer think about security after we finish a cycle. Instead, we think about it all the time. Such perspective transforms the culture, process, and tooling we need in DevSecOps. Let us first look at the difference between the traditional and the new ways. Table 1 explains the lucidity. Well, let me see how many minutes I got. I got about 8 minutes. We're going to do about 45-minute video. We're going to get through at least chapter 1. Traditional security management. Security outsourced. New way. Security team is part of the team. So yeah, that makes sense. Security operation happens after each software release. Security operation is integrated. Manual and tool-based security scanning. Least manual intervention, scanning, and data segregation are automated. The development team only knows about the security issues after the release, and the security team provides feedback. Each member of the software development and IT operation must be aware of the security aspects. So this is where it's at now, the new DevSecOps. Basically, we see a clear difference in the approach and process in adopting DevSecOps. For an organization, the culture will change and the process will incorporate the security controls at each stage with engagement from each member of the team. We'll discuss this in the following sections. Adopting DevSecOps key changes. DevSecOps. DevSecOps blends software development and IT operations with tightly integrated security operations. We look at the whole process from a new perspective now. The team is now closely integrated. The team culture reflects the close collaboration of various skills, people for the common goal, secured, agile digital infrastructure. As we outlined before, the process, tools, and techniques are now different. However, these can be understood through the key changes: lean, automation, measurement, ecosystem, interoperability. Man, reading phases this point. All right, so lean, measurement. Let me look right here. So lean, measurement, ecosystem, automation, software development, IT, security operations, interoperability. Roper. We shall discuss these four key changes in detail for a better understanding of DevSecOps and to prepare us to adopt the new paradigm. Lean process. It is widely popular to adopt lean processes in project management. This approach in software industry is embodied by the agile methodology. It asks to split the project into many small phases, each spanning over a week or two. Each phase runs in a quick succession with a cycle of planning, execution, and feedback. This approach restricts the team from straying from the project scope, timeline, or costs. Discussion on challenges to be discussed, Chapter 7, Digital Transformation and DevSecOps. It also encourages minimal yet meaningful documentation to maintain and track. Illustration: a typical lean agile cycle is feedback. Oh, wait, hold up. A lean agile cycle is to plan, execute with feedback. Plan, execute, feedback. Agile versus DevSecOps, no contradiction. Agile methodology is extended and enhanced in DevSecOps. Each stage of DevSecOps cycle follows the agile process within itself. We shall see how this is implemented as we make our journey through the book. We shall discuss planning and security in detail later in the chapter. The execute pertains to the activity pointed by the name of the stage of DevSecOps cycle. The feedback is rapid after each stage. The speed itself leads to the next driver, automation. Automation. Like any other industry, software making and management strives to reduce costs and defects. Of course, this is another aspect in increasing the speed of delivery. The exponential growth in the requirements of software applications happened due to the unhindered intervention of digital technologies in the business landscape. Moreover, the rapid evolution in the digital technologies makes the challenge to current software architecture, technologies, and distribution faster. The essential point here is that the ever increasing delivery speed of the software IT is the order of the day. It is important for a successful customer journey to be covered in detail in Chapter 7, Digital Transformation and DevSecOps. Better adoption of a software product and greater satisfaction for the customer. The only way we can move fast is if we automate the process. The hell did that? That was just stupid, redundant. However, automation needs to be a significant change in our perspective and approach to the adoption of the right tools and techniques to be covered in Chapter 5, automation. I can't stand when there's just so much, not fluff, but just ridiculous detail to try to make something sound more important or more complicated than it has to be. Did they really have to say all that about automation? I mean, I would say that last paragraph is all they needed in this. Anyways, just keep moving on. Measurement. We strive to do our best while managing software development. IT operations or even security operations, it would undoubtedly be an advantage to understand the process, enhancement, and success quantitatively. It is further important as we must choose from many available programming languages, platform architectures, frameworks, and databases based on performance, long term cost, technicalities, and debts. See that? That was a perfect paragraph. That was it. There's all this other crap here. Debt is a liability that results from poor design, coding, or choice of technologies or code bases. We shall discuss technical liabilities and debt in Chapter 7, Digital Transformation and DevOps. We also shall learn the tools and techniques for measuring the performance of a process or product in the next chapter. The whole process is the value stream management, VSM, that promotes tracking and controlling software delivery from the organization. For DevSecOps, we use the two sets of metrics to measure. DORA metrics stands for the DevOps Research and Assessment Team. Its four metrics are deployment frequency, DF, lead time for changes, LT, man time for recovery, MTTR, and change failure rate, CFR. Flow metrics. It measures how value moves through the value stream of a software product with its five metrics: velocity, efficiency, time, load, and distribution. While the later is more comprehensive, the first one is popular due to its simplicity. We shall discuss these great details in Chapter 7, Digital Transformation and DevOps. Ecosystem interoperability. Man, even though the trinity of the cloud, AWS, GCP, and Azure, so AWS is Amazon Cloud Services, GCP is Google Cloud Services, and Azure is Windows Cloud Services. You should Google those. I got a book that I'm gonna go through on these, and it seems pretty interesting. But that'll be my next video. It's currently because this is another thing that employers are asking for. If you have any web experience or online data storage experience. Anyways, it's currently ruling, and you may have to opt for tools available in the cloud systems ecosystem entirely or partly. Even if you work with the mainstream, read popular cloud ecosystems, you may have to work across more than one. Also, this will be our approach throughout the book. We shall discuss the advantages and disadvantages of adopting cloud services of a particular ecosystem when we cover a usage scenario. Present Figure 1.5 presents four major influencers that demand interoperability. Interoperability, and across the clouds and hybrid systems. Influencers of ecosystem interoperability. Interoperability. Shared processes, data models and configurations, microservices and containers, cloud APIs. The major challenge of multi-cloud management is identifying and aligning the shared processes. DevSecOps culture must permeate across ecosystems. Development tools across the aisles must be integrated. Security processes and visibility must be uniform. Configuration management and across clouds must be aligned. One good thing about all the available ecosystem is that they support microservices, to be discussed in Chapter 2, Application Security in great detail, and REST APIs to integrate different parts of your software system. They may also provide code samples in your preferred programming language. However, sometimes you may want to migrate from one service and ecosystem to its counterpart in another. Let me see, where was I at? The reason can be the cost, performance, regulatory compliance, or even customer demand, such as situations through usual challenges, resiliency of our solutions. While we will discuss this with several examples in the book, this is a typical case migration. It can be simple, like moving transactional emailing from Mailgun to Twilio. It can be complex, like a SaaS application. If you don't know what SaaS stands for, Google it. Deployed in multiple geographical regions on one cloud ecosystem to move to another. Another way to move across ecosystems is using containers like Docker and Kubernetes. Nettes? Kubernetes? Anyways, to be discussed in Chapter 4, Containers and Security in Detail. Unlike microservers, unlike microservices, these enable us to move the software units to different clouds. While traditional infrastructure provisioning requires an elaborate process, provisioning of infrastructure on the cloud is fast and simple to scale and manage. We will discuss methods further later in this chapter. Here it is imperative to understand the differences between design and documentation, process in old and new ways. We are responsible for successful software and digital infrastructure lifecycle management. The documentation of new and old ways. The need for documentation has become more relevant with the speed of changes due to faster software, development infrastructure, and configuration management. The documentation is now treated as actionable items during the design phase. You can generate code and configuration based on design. On the other hand, documentation must self validate with actual systems for audit availability. Table 1.2 lists the differences between the old and new design. Old way, architectural details are maintained through an extensive documentation in the form of ebooks, including UML diagrams and data flow diagrams. New way, architectural diagrams with notes specific to public cloud ecosystems, low code platforms, or programming frameworks are recorded. I have no idea what that means. Infra- Infrastructure details are recorded in the form of network diagrams with each asset listed, the configuration, and the way they linked with one another. While the top level infrastructure diagram is maintained for the business team's consumption, the configuration details are kept with a special configuration files that are generated or managed through cloud specific tools or even by simply editing JSON or YML files. If you don't know what a JSON, you know what JSON is, Google it. UI designs are usually in graphics and notes associated with these. UI is more functional with the possibility of generating front end code. Test cases are maintained through spreadsheets or something with software like SmartBears. Test cases are managed with a cloud-based software using intimately connected to the CI or CD pipeline. Coding is done through code editors. Coding is done through a code editor either locally or on the cloud. These are the equivalents when we make the transition from traditional ways to planning the DevSecOps. Security interventions are planned at each step. Security controls. While working on DevSecOps, we need to understand the security interventions during each cycle. These are security controls and help us deliver secure software. So this is where we want to know. Table 1.3 provides the list of security controls at each stage of DevSecOps. Okay, there we go. Security number one, DevSec DevOps stage design, security intervention, threat modeling, secure coding, standards, security policies. So you'd be like, okay, you're we're designing this code. We need to take the security part of it of your DevOps and the design. We need to figure out, we need to do some threat modeling. We need to secure. We need to get the secured coding standards down, and we need to get our security policies in order, in line, right? What security policies are we following and stuff like that. I'm not going to give no examples. I'm just going to keep reading. It'll take too long. So code, in the coding part. So when the programmers are coding, or let's say I'm a programmer too, right? And I'm coding. We're gonna the security part of the DevSecOps would be static application security testing. So you're just testing for security vulnerabilities, I guess. I don't know. I hope they explain all this here in a second. Security unit and functional testing. Okay, so you're just doing testing. In the integrate phase of DevOps, we're going to do the security side of it, the SecOps side of it, software management. So we need to have a secure management process, dependency dynamic application security testing. Okay, and this is more testing. Um, so we're going to have to go deeper into that. Okay, so deploy, live site penetration testing. See, the thing is, are companies doing that? I mean, I'm sure the bigger ones are. They have their own penetration testing teams that are doing that. Web application firewall configuration testing, and that's what IT, or somebody that's pen testing the firewall. I have no clue. Digital inventory management, okay, and configuration testing. All right. Yeah. Seems to me like they took DevOps and they just integrated security testing into the DevOps. That's exactly what they did. Yeah. So, yeah. Operate continuous monitoring, infrastructure scanning, access and activity logging. Yeah, it's just the IT side, but they're matching it up with the DevOps. I don't know. Monitor, security audit and monitoring feedback, security training and assessment. That's pretty interesting. However, it is important that we understand the goal of having security controls. In the following subsection, we shall discuss the broad goals of security. Goals of security. There are three goals which we act like pillars and guide us to implement and guide us to implement security controls in the DevSecOps process. Okay, what are the pillars? The CIA triad. So let's just read this. Confidentiality. The confidentiality of data is very critical when the data is in storage, when it is in process, or when it's in transit. It is about uh, making the data accessible to only those who have permission. The confidentiality of data is stored in storage is ensured by different encryption mechanisms. The mechanisms of protecting data during this process is known as confidential computing. Data in transit gets its protection from HTTPS encryption. So confidentiality is the is the what's that saying? The process of just protecting the data and making it accessible while protecting it. And it has to be, the only certain people have to have permissions. Your authority or your authorizing needs to be set up and all that stuff, right? Okay, confidentiality. Integrity of data means that the data cannot be changed in an undesirable manner. Only valid users can access and modify the data in an expected way for which the application has been designed. We shall discuss this. Chapter 2, the encryption and decryption data, maintaining immutable data records during the workflows. Availability, and this is the CIA triad. Now, you guys can Google that and study it better in more detail. Availability, the software system must be accessible at any time the valid end user needs it. The system must be available. We shall discuss this in the context of infrastructure provisioning, high availability architecture. Later in the chapter, we shall also discuss the availability of the application, or even when one or more parts are unavailable. We'll decipher and elaborate in the remaining sections of this chapter. Documentation and security. The most critical component of all activities in DevSecOps is documentation. Actionable and trackable documentation. The documentation must be prepared concerning architecture, infrastructure provisioning, UI, database functional systems, and test cases. Usually, such a thing is initiated at the start of the project but then evolves. There are multiple frameworks for document management, while agile practices, information technology infrastructure library, ITIL, IT service management, ITSM, for example, ISO IEC to 20,000, and information security management, ISM, for example, ISO IEC 2701, are quite popular in documentation different aspects. DevSecOps pushes actionable characters in such efforts. We'll discuss these more in later chapter 6. While it is while it would have been a happy situation in the pre-DevSecOps regime to manage the documentation in word processor programs, of course illustrations and diagrams are done through respective programs. We aim now to automate documentation creation and validation after we put the higher levels of details. With a major focus on automation and speed, auto-validation of configurations, database and codes against the best practices and standards is the way to go. Moreover, the feedback at each stage in auto mitigation is a cardinal feature of DevSecOps process. Feedback can be in the form of alert, responsibility party, an individual with a specific role with a clear set of access privileges, yada yada yada. Threat modeling and security policies. Threat modeling is the process of identifying the threats to the software product and its delivery and mitigating them proactively and cost effectively. A threat may be a failure to do the wrong or inadequate. A threat may be a failure due to wrong or inadequate configurations in the system or unwanted external interventions like DOS attacks. Different frameworks exist to guide threat modeling. So, framework Stride, created by Microsoft, it draws its name from the acronym spoofing, impersonate, attack, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. CVSS, acronym for Visual, Agile, and Simple Threat, uses an automated threat modeling method by threat modeler. PASTA acronym for Process for Attack Simulation and Threat Analysis. Uses a seven-step process. HTML hybrid threat modeling method developed by Security Equipment Inc. SEI. Trike uses a method to define the system's assets and actors. 5-point probability scale for each crude action and actor. Attack trees uses charts to display the possible paths of security attacks in the system. Security wildcards uses creative thinking and brainstorming rather than structured threat modeling approaches. Yeah, I'd probably go with that one. Some tools support the DevSecOps cycle, and one or more of these frameworks. Examples include OWASP's Threat Dragon and Threat Modeler platform. ThreatModeler.com. That take me to a link. Nope. We will discuss threat modeling frameworks and tools and details in Chapter 6. While threat modeling helps ascertain security threats, we need well-laid policies and procedures for planning, secure coding standards, change management, and process auditing. ISO information security management systems lead in laying such of the frameworks. Why do they keep putting the acronym here if they've already explained it once? Just keep doing it, ISMS. We've already seen it, no? Maybe not. The way we write such policies have undergone significant changes in the past decade. The considerable increase in security threats and speed of software deliveries have put the on us on continuous tracking of process parameters and actions. Man, say that 5 times fast. Based on feedback received, and it can be possible by gearing up our infrastructure and code management towards this. Infrastructure provisioning and security. Man, how long is this chapter? Oh, okay. I'm gonna have to speed this up. With levels of automation, we expect the traditional way of managing infrastructure provisioning and security has become a thing of the past. We need rapid provisioning and scaling with ensuring that the application remains available to its end users. This is possible due to the configuration of infrastructure and high availability infrastructure. So we're probably going to have to just stop there and pick up on another video. Um, these are pretty long chapters, but we're almost to there. We'll do a couple of videos on this. Um, yeah, DevSecOps is the new buzzword apparently, and um, I think this book is valuable. I think going through this, I don't know if I'm gonna uh, go make too many videos of this. I might not. But this is just a taste of what DevSecOps is, right? And if you want to get the book, let's look. It's how do I go to that first? Let's go to the first introduction. Yeah, so it's concepts and practices of DevSecOps. Crack the DevSecOps interviews. So I would recommend this book by Ashwini Kumar Rath. Um, like I said, a lot of these jobs are asking if people have DevSecOps experience. Here, just by reading that, like introduction of what DevSecOps is, I would say if you've been in cybersecurity and you've been a programmer, I say you do have experience with DevSecOps. Now, you might not know the ins and outs and ends of this, of where they're putting their concepts. See, and that's one thing I can't stand. I can't stand that. Like now we have to, there's DevSecOps now. So a lot of these employers are saying, yeah, do you know about Dev? You need to know about the DevSec. How many years of DevSecOps do you have? Uh, None, because it's like new, or is it not new? I don't know how old it is. But DevOps, yeah, people have many years of DevOps experience if they were software developers and they were using the DevOps um, infinite loop that we looked at earlier, right? But now we're in cybersecurity, or even programmers that now they're doing DevSecOps because cybersecurity is integrating with in everything now, right? But before it was like they said, third party people were doing the IT part, or IT department was doing it after your software was developed. Now they're just integrating it in between. So I mean that's basically it. All right, so I'm done. I hope you liked this video. Like and subscribe if you did. If you guys want me to do more chapters on this book, let me know and I can. All right, that was Hackthefile. Have fun. Enjoy.